Hello guys, welcome back to my channel. So in this video, I'll try to answer and continue about the Newton's law worksheet. If you haven't seen my first answer, you can try to see on the first part, which is I'll try to post the link in the comment on description box below. So we'll get started. So I'm going to continue, started from number 11. A 5 kg block is pulled across a table by a horizontal force 40 Newton with a frictional force of 8 Newton opposing the motions. So if you can draw the situations, so this is a box which has a mass of 5 kg like this. So this is 5 kg, which is, this is the mass of 5 kg, right? So the weight itself should be 15 Newton. And the force, horizontal force, we assume that it goes to the right here. And the frictional force is always opposing the direction. So it's going to the left. It's 8 Newton. If you want to find the accelerations, you can use the formula of this, Newton's second law, But in F here is the net force. It means that it's the total force is 40 minus 8. So 40 minus 8 equals to mass is 5A. So in this case, 32 equals to 5A. So the accelerations here is 32 divided with 5. It's 6.4 meter per second square. As you can see, in this calculations, we didn't include the 15 Newton here because that's the weight, The motion of the block is horizontally. So the force we count is only the horizontal force, All right, next. We continue with number 12. An object of mass 30 kg is in free fall in vacuum where there is no air resistance. Determine the accelerations of the object. So if you can draw, so this is the weight. The weight is 300 Newton, right? Yes. Now determine the accelerations, right? The accelerations actually, if you want to use this formula, all right. So the mass is 30, right? This is the accelerations, and the F itself is this, because there is no such air resistance, There is no. You can assume this is 0 Newton. So here is 300. So the acceleration here is 10 meter per second square. Basically, it's the gravitational accelerations. Gravitational accelerations. That's the answer for number 13. I mean 12, sorry. So next, number 13. An object of mass 30 kg is falling in air and experiences a force due to a resistance of 50 newtons. Determine the net force on the object. Okay, the net force, we draw once again like this. The mass is 30 kg. It means the weight. How do you calculate the weight? I'll tell you now. Okay, the weight is using this formula, Weight is 30 multiplied with 10. 10 is for the gravity, so it's 300. So it's going down, it's 300 Newton, and there is an air resistance about 50 Newtons, of course, going up, opposing the directions, So the net force here is 300 minus 50 is 250 Newtons going down, right? Going down. Now the accelerations, you can use this formula again. With this force is the net force, and the mass is 30. So the acceleration here is 8.33 meter per second square. That's the answer for number 13. We continue with number 14. The student pushes on a crate with a force of 100 Newton directed to the right. So he pushes 100 Newton to the right. What force does the crate exert on the students? So what's force? So based on the third Newton law that say every action will give an equal balanced reactions, but just the opposite directions. So the value of force that the crate does exert on the student is 100 Newton. Basically, yeah, it's going to the left. Yeah, equal, yeah, but it's just the opposite directions. Okay, move with number 15. A force of 200 Newton exerted on an object of mass 40 kg that is located on blah, blah, blah. Okay. Perfectly smooth ice, it means that there is no friction. Calculate the accelerations. So, the acceleration, this is 200, the mass is 40. So, the A itself is 5 meters per second square. If a second object identical to the first object is placed on the top of the first object, what acceleration will the 200 force produce? So it means that there are now two kinds. Yeah, identical means they have the same mass. So it means that the mass now is double, right? So it's 40 plus 40. It means the mass become 80. The acceleration itself became, yeah, it's 2.5 meters per second. Yeah, they will move, but it's slower, yeah, compared to the first one, yeah, because they have the bigger mass, yeah. All right, next, number 16. Just before opening her parachute, a skydiver of mass 50 kg reached terminal velocity. Calculate the force of air resistance. So it means that the force is equals to mass multiplied with accelerations. So 50 multiplied, now in here, we have to use the acceleration of gravity. You can assume 10. So the answer is 500 Newton. Next, we have still two problems to solve. Number 17, for a person who has a mass of 60 kg, calculate the weight in Newton. So the weight itself is mass multiplied with gravity. You can assume 10, so it's 600 Newton. If 1 pound, yeah, you should read this pound, yeah. 1 pound equals to 4.45 Newton, then what's the person's weight in pound? So in this case, 600 divided with this is the person's weight in pound. Yeah. But I don't think in Indonesia, this kind of problem will come out in your test, yeah. Yeah, but maybe in overseas, maybe, yeah. Because we in Indonesia doesn't use pound as the usual units in our daily life. All right, so number 18, the last one. An object has a mass of 10 kg accelerated upward. So what force required? So F equals M multiplied with A, 10 multiplied with 2, yeah? So it means that 20 Newton. That's the force required. All right. I hope you enjoyed this video, and I hope also you have a better understanding now about Newton's law. So we'll see on the next video. Thank you.